Hello everybody and welcome to Combustion. My name is Marissa and I'm going to be your scientist for today. Now we're going to be exploring the science of combustion, so I'd like you all to take a moment and think in your head, what does combustion mean? What do you think of when you think of the word combustion? Got it? All right, great. Now before I do that, anytime during the show, right before I do something really cool, I'm going to look at you and I'm going to do this. And all together we'll say 3, 2, 1. You can say that at home too. Now first I'm going to put on my safety goggles. There we go. And let's see what combustion looks like on a countdown of 3, 2, 1. Whoa, look at that. That is combustion. Combustion is the term for the chemical process that gives us fire. I'm going to put this right over here. Now there are 3 ingredients to combustion and we are going to find out what all 3 of those ingredients are. But first, we need to talk a little bit about safety. Kids, do you think you should be safe around fire? Yes, you should. Adults, do you think you should be safe around fire? You should. So let's all take the Pacific Science Center safety oath. Everybody raise your hand, even you at home, and repeat after me. I promise that if I use fire, I will always be safe. Wonderful. Give yourselves a round of applause. Now I am being safe because I have my safety goggles. I have 2 safety fire extinguishers, one there, one down there, and I have some safety cones right here in front. Now I'm going to move this out of the way because I think it is time we talk about the first ingredient. Now for the first ingredient, I'd like you all to imagine something. Imagine we are all out camping together. We are out in the forest. Imagine the sun is starting to set. It's getting kind of dark. It's getting a little bit cold. Now there's something that we might want, and I think that might be a campfire. So imagine we've built a campfire and we want to keep that campfire going all night long. There's different things we can put into it. I think I might put in some wood to the campfire, maybe some sticks, maybe some bark, maybe some leaves. You might be able to think of some other things you can put into the campfire. Now there's a special name for all of these things that can light on fire and burn. And that very special name is fuel. Fuel is the first ingredient of combustion. I'm going to put this up right here. Now you might already know some fuels, things like wood or paper, but I bet I have a few other fuels with me up here today. For example, I have these candles right here. Do you think these candles are fuels? Let's find out. I'm going to try to light this candle on fire. Aha, that looks like a fuel to me. I'm going to light this one too, my backup candle. Always good to have a backup candle. All right, so candles are fuels. What else do I have? I also have a match right here. Let's find out if this match is a fuel. Here we go. Looks like a fuel to me. All right, so candles are fuels, matches are fuels. What else do I have here? I have my metal table. Let's see if this metal table is a fuel. I'm going to try to light it on fire after a 3, 2, 1 countdown. Here we go. 3, 2, 1. Come on, burn. 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 Is that a fuel? No, it is not. So my metal table is not a fuel. Do you think that means that metals can't be fuels? Let's think about that a minute. I have another metal to test out. A different kind of metal than my big table. It's a lot smaller too. It is a kind of metal called magnesium. Magnesium metal. Let's find out if magnesium is a fuel. Now I'm going to put this magnesium metal into this candle. It could burn pretty bright. So I'm going to make sure not to look directly at it. Out of the corner of my eye, I'm going to see if this magnesium metal will catch on fire and burn. Aha, there it is. Now you might notice this magnesium metal is burning a different color. It was burning bright white. Now, my friends, metals can burn in different colors. I have a few other metals with me here today. These metals are a little bit different because they are suspended in a liquid, and that liquid is called isopropyl alcohol. I have some isopropyl alcohol here all on its own without any metals added. Let's start by seeing what that looks like when it burns. Here we go. I'm going to spray it onto my candle after a 3, 2, 1 countdown. Here we go. 3, 2, 1. Whoa. As you can see, isopropyl alcohol is a pretty good fuel. Now, in these other bottles of isopropyl alcohol, as I said earlier, I have added something to them. I've added different kinds of metals. This one has a metal called strontium chloride. Let's see what this looks like when it burns. Here we go on a countdown of 3, 2, 1. Whoa, look at what color that is. Do you see what color that's burning? It's burning red. Strontium metal burns red. Now I'm going to relight my candles because I put them out. There we go. And I do have one other bottle with me here, another bottle full of isopropyl alcohol plus a little something special. In this one, the metal I've added to it is called copper sulfate. Let's see what this looks like when it burns. Let me get this working. There we go. On a countdown of 3, 2, 1. Do you see what color that is? It burns green. Copper burns green. So I have this one bottle full of a metal that burns red and another bottle full of a metal that burns green. What do you think it would look like if I sprayed them both at the same time? Let's do it. Here we go. On a countdown of 3, 2, 1. Whoa! What color do you see on the tip there? Do you see some tealish blue? And that, my friends, are some pretty neat fuels. Excellent. So we've discovered a lot of fuels, but there are 2 more ingredients to go. So let's move on to the next one. For the next fuel, I have some more isopropyl alcohol in this container right here, and I have a very special prop. I have a $1 bill. Now, this $1 bill is made out of a special kind of paper, a paper made with cotton and linen. Do you think those are fuels? I'll give you a spoiler, they are. So I'm going to try to burn up this $1 bill. But just to make sure it burns, I am going to soak it in more of that isopropyl alcohol I have right here. I'm going to take this $1 bill and I'm going to stick it in this container. I'm going to make sure it is well and truly soaked. There we go. Plenty of isopropyl alcohol on it. Awesome. I'm going to scrape off the extra liquid just so it doesn't drip too much. And I'm going to try to burn up this $1 bill on a countdown of 3, 2, 1. Here we go. Oh, look at that, folks. Money on fire. That didn't quite work. I think I'll try that again. Science is all about trying things more than once. Let's see. Once again, I'm going to stick this $1 bill into this isopropyl alcohol. I'm going to get it nice and soaked. Here we go. I'm going to take it out. And once again, I will try to burn up my $1 bill. Here we go. On a countdown of 3, 2, 1. There it is, there it is, there it is, and it's gone. All right, let's see what's going on here. It doesn't even feel hot right now. I'm also noticing it's still wet. It's soaking wet, and that alcohol should have burned off. But here's the thing. I didn't tell you everything. There is some water in with this isopropyl alcohol. Water is really, really good at absorbing heat. So while the alcohol burned off, the water absorbed all the heat and it protected my dollar bill from burning. So that means there was not enough heat for it to burn. If there wasn't enough heat, that means heat must be our second ingredient. Here it is, right over here. So we've got fuel, we've got heat, 2 down and 1 to go. Speaking of fuels, there is another fuel I want to show you. It's a pretty neat one. It's in this jar right here, and it is called Lycopodium Powder. Kind of a long word. Lycopodium powder are the spores of a kind of club moss, and it is very, very flammable. It's very good at catching on fire. At the very beginning of this show, I blew into that can back there, and a flame shot up out of it. This was the fuel I used for that experiment. And in fact, I only used about this much, about half a teaspoon of Lycopodium powder to get a flame that went like this high, which is pretty neat, right? I think. But we've seen a lot of really cool things at this point, and I really want to impress you, so I'm going to try something else now. I'm going to try a bit more than just one scoop of Lycopodium powder. I'm going to try like 1, 2, 3. I'm just going to take this whole big scoop here. Like that. And I am going to add heat to it. This is a great idea. I'm sure of it. Here we go. So I've got my fuel right there, just like it says over here. Next, I need my heat. I will use 1 match for that. There we go. Now, fuel and heat. Let's see what kind of combustion we get. Here we go. I'm going to keep my face back here. Okay, hold on a second. I had my fuel. I had my heat. I might be missing that third ingredient. Now I can add the third ingredient, but in order to do that, I will have to attempt the most difficult experiment in this whole show. To make this happen, I need to take 1 scoop of this highly flammable Lycopodium powder, and I need to put this fuel into my own bare hand. Like so. So that's my fuel. Next, I need heat, so I will take 2 matches. 1 and 2. I will light these matches on fire. And I will put them into my bare hand as well. All right. And I will add the third ingredient in 3, 2, 1. Combustion. Now, you might have noticed that I threw that fuel up into the air, and that, my friends, is the third ingredient. Well, something in the air. Everyone, take a deep breath in. Let it back out. There is something we all need out of the air, and that is called oxygen. Combustion needs oxygen as well. Here it is, written down right over here. So we have fuel, we have heat, and we have oxygen. And with that, we finished up our combustion triangle. Good job, folks. Folks at home, give yourselves a round of applause. That's wonderful. Now I'm going to package up this Lycopodium powder. It is a pretty awesome fuel, but it's not a fuel that you're going to run into in your everyday lives, probably. You're a lot more likely to run into a fuel like this one right here. This right here is just a regular old cotton ball. Now, your clothes are often made out of cotton, and there's something you're supposed to do if your clothes catch on fire, and that is stop, drop, and roll. Everyone say this with me. Stop, drop, and roll. I will demonstrate for you. I'm going to stick my cotton ball into the fire. Oh no, it's on fire. What do I do? Number 1, I stop. Number 2, I drop. Number 3, I roll, and that cuts off the oxygen to put out the fire. Now, I have another kind of cotton with me here. It's a very special kind of cotton called flash cotton. And this stuff is special because it has oxygen chemically added to its very fibers. Let's see what that looks like. Here we go. I've got a piece right here. On a countdown of 3. That was pretty fast. Let me try that again. I've got another piece. This time I won't count down. This time let's just watch very, very carefully to see when this combusts. And let's listen very, very carefully to see if we can hear it. Here we go. Oh, did you see that? It wasn't even touching the flame. So when you add extra oxygen to a fuel, it burns faster, bigger, and louder. And that's why oxygen is my favorite ingredient. All right, my friends, we have learned the 3 ingredients to make combustion. We've seen with them we can get fires, we can get fireballs, but there is one more thing we can get. That last thing we can get is explosions. Would you like to see an explosion today? I hope so. Here we go. Now I have a balloon with me here. This balloon is full of a gas. Sometimes taking balloons, filling them with gases, and lighting them on fire can make some pretty exciting explosions happen. The gas in this balloon is called helium, helium gas. You might be familiar with that. Birthday balloons are often filled with helium gas. Now I'd like you all to take a moment to think to yourself, do you think helium is a fuel? Just make a guess. If you don't know, that's okay. We are going to find out. This could make a loud noise. I don't like loud noises, so I'm going to cover up my ears with some hearing protection. Safety first, as always. And I'm going to take this fancy lighter here. I'm going to bring this lighter up to my balloon. Now the heat will burst the balloon. The gas inside, helium, will mix with the oxygen in the air and the heat of the lighter. And if helium is a fuel, we will see combustion happen. Here we go. On a countdown of 3, 2, 1. That was not very exciting. Did anyone see any big fireballs? I sure didn't. Now, helium, my friends, is not a fuel. It is something called a noble gas, and noble gases don't combust. But I do have another balloon with me here. And this balloon has a different gas in it. Everyone say hello to hydrogen. This balloon is filled with hydrogen gas. Now think to yourselves for a moment, do you think hydrogen is a fuel? If you don't know, that's okay. We are going to find out. Now once again, I'm going to cover my ears with some hearing protection. I don't really like loud noises. Once again, I'm going to take this fancy lighter. I'm going to bring it up to the balloon. The heat will burst the balloon. The gas inside, hydrogen this time, will mix with oxygen and heat. And if it is a fuel, we will see a giant fireball. Here we go. On a countdown of 3, 2, 1. Look at that. Hydrogen, my friends, is a fuel. Now that was pretty awesome. But I do have a second hydrogen balloon with me. And I thought for the grand finale of this show, I might take it out. And I might do something else as well, and that is turn down the lights so we can really see it in all of its glory. Here we go. Here is my second hydrogen balloon. I'm going to attach it up here at the very top. And then I'm going to bring the ribbon all the way down. Safety first, as always. Here we go. And I'm going to run in the back and turn off the lights. All right, folks, all together. Fuel, heat, oxygen! Combustion, everybody. Thank you all so much for coming. That was the Combustion Show. If you have any questions or comments, feel free to add a comment to the video. Otherwise, have a great rest of your day, folks. Thank you for watching.